Welcome. We are solving day 13 advent of code. I've read the problem but haven't thought of any solution yet. The question is simple. You are given this grid and we need to find out the mirror images of a certain vertical line. So a vertical line will be between two adjacent columns. So as you can see, this line between column 5 and 6, we need to find out this mirror portion. So as you can see, this is exactly mirror with this. You can neglect the column which doesn't have any matching column to the right, and we need to do this for horizontal lines as well. So as you can see, if this is the horizontal line between row 4 and 5, then it has 3 rows below and 4 rows above. So you need to check whether these 3 rows below match with 3 rows above it. You can ignore this because it doesn't have any matching to do with the 8th row since it is not available, and there is some number multiplied by for each grid. One more thing that I need to check is, do we have to do this for all vertical lines or is it anything constrained? Doesn't need to match anything. To summarize your pattern nodes, add up the number of columns to the left of each vertical line of reflection. Each vertical line of reflection, right? So it must be between non-empty grids, right? Find the reflection in between. To find a perfect reflection across either a vertical line between 2 rows or this. And the first pattern reflection is a cross vertical line between 2 columns. Arrows on each of the 2 columns point as the line between them. Okay, fine. So for each column there would be m-1 of these, and each horizontal column there would be n-1 of these. We need to check whether it is a reflection. To check the reflection, what I was thinking is we start with these pointers, let's say I and j, and we keep on expanding them, pushing the left to the left and right to the right. As long as they are inside the grid, we compare. If they are not, we can end the iteration and say that okay, this is a reflection. We do it for all the rows, and for all of them, if it matches, then that means that particular vertical line is good. But to summarize your pattern nodes, add up the number of columns to the left of each vertical line of reflection. To that also add 100 multiplied. Okay, if we do this for a fixed vertical column, we need to add the number of columns to the left of that plus 100 multiplied by the number of rows for each. For example, for each line we need to sum up all the results, right? Find the line of reflection in each of the patterns in your notes. What number do we get after summarizing all your notes? I hope this summarizing means summing up. It's a bit confusing that way. Okay, these are the 2 inputs and what is given to us. The first pattern's answer would be, just give me a minute. let's start with the implementation. Use 23, create day 13. Is this the only answer? I hope so. Let's take this and put. Let me do one thing. Whenever there is a dollar, I say that I need to start taking the new grid, right? So first time I encounter this, I will clear the grid, check if it is the new test case. Fine. For the last test case, I will answer for this is 405. Test. Okay, this is very large. Now I can do one thing. I can substitute the new lines dollar, I guess, or I can do it like this. Okay, dollar. Let's say 50 at the rate A. Okay. There are still more grids available, so I will remove this $1 at the end. So this I am doing because I need to read the lines between each individual grids one after the other. So that I say that the input for this is now over, so that you can consider these lines in the next grid. Okay. Let's do it for the sample test case first. We have do it like this, I guess. Much string line also. So vector of string is the current grid. If line is the string, and if grid is not empty, I can send it to solve the answer for this particular grid. And I also need to clear the grid now, else we can simply add those rows in this, right? This will also be helpful when there is a dollar at the end. Whenever this dollar is occurred, we don't send that empty grid to solve, but when this dollar occurs, then this entire grid would be sent to the solve function. and we need to clear it as well. That is what I have done here. Okay, let's write the function for main logic. What do we need to do? Return answer for solve. It's a mat rows. I haven't enabled screen key today, I guess. Do that quickly. Number of rows and columns. Let's take it as a const reference. I will go over the indices from 1 to n minus 1. Row from 1 to n minus 1. And so I'm first checking the answer for horizontal lines. So in this case, we need to do this for all the columns, right? For column n 0 to m minus 1. The row above it, the coordinate for that would be 2 minus 1, and column next, the row next to that would be row, and as long as r1 is greater than equals to 0 and r2 is less than n, r1 will go above. So let's say we are at row 5 and column 0, so this would be r1, this would be r1, r2. We need to do what here? 5 columns. Do they? Four columns above it. Okay, fine. This variable will say that it is a good line or not, and I also need to count up columns. So this would mean to check r1 of this column is same as r2 of the same column. Then we will change, sorry, it should be r2, r1 minus minus, and r2 plus plus, because we will take this row above and the r2 row down as long as they are inside. But this will make one thing wrong, which will be like, I'm counting this up, right? So this will end after 3 iterations, so this would be 3, but up should be 4, which is the number of columns above it. So this value is think this should go here, and if good, then the number of rows above this horizontal line is simply row, and we need to add a multiplication factor of 100 for it. So let's do that. Answer is 0. answer plus equals to 100 times number of rows above it. Perfect. So let's do it for columns from 1 to m minus 1. I am writing this once again, not copy pasting from the other, so that I am sure that I'm not messing up the variable names anywhere. Here I will fix a column, and C1 would be col minus 1, C2 would be col. And while C1 is equals to 0, C2 is less than m, which is this width. And for this, I need to check the number of columns to the left of it, right? The columns to the left of it. So 1, 2, 3, 4, 5. And the same condition here as well. Code and equals to mat of row of C1 minus minus is equals to mat of row of C2 plus plus. And what else? If it is a code, we need to add only the number of columns to the left of it, which is this value, and return answer from here. Okay, let's call it a solve function only. Solve part 1. And this will print out the answer. Yes. Let's check. Is there anything wrong? Okay. Is the issue? Is wrong here? Do I have in one? Yes. Should be okay. See, 405. Perfect. Let's try it on the large test case. But before that, I need to remove the hard-coded file reader. Looks fine. Run it on last test case. Correct answer. Cool. Let me take the backup first. You resume walking through the valley of mirrors and smack run directly into one property. On closer inspection, you discover that every mirror has exactly once much. Exactly what? Exactly one dot or hash should be the opposite type. In each pattern, you need to locate and fix the smudge that causes a different reflection line to the valley. The old reflection line won't necessarily continue well after the smudge is fixed. Here is one example again of these tests. The first pattern is in the top left corner. If the top left corner is a Top left, how is it a dot? Okay, no. Smudge is in the top left corner. Top left, is this right? What are they talking about? Okay, after changing, so top left hash were a dot, then this would be the new grid. It would have a different horizontal line of reflection, okay, which would be this one. With the smudge in the top left corner repaired, a new horizontal line of reflection between row and final now exists in row 7 has no corresponding reflection in row and can be ignored. Row 7 has no corresponding reflected row. Okay, this can be ignored means we only need to consider the minimum of those, right? So that's fine. I'm confusing it with something else. Can be ignored, but every other row matches exactly. That's fine. Okay. In the second pattern, this much can be fixed by changing the fifth symbol. Okay, the changing now pattern has different horizontal line of reflection between rows and 1 and 2. Okay, understood. Summarize your notes as before, but instead use a new different reflection lines. In this example, the first pattern's new horizontal line has 3 rows about it, and summarizing it to this value. In each pattern, fix the smudge and find a different line of reflection. What number do we get after summarizing the new reflection in each pattern in your notes? In each pattern, fix the smudge and find the different line of reflection. What number do you get after summarizing the new reflection line in each pattern in your notes? One thing I want to make clear is, do I have the option to change every dot to a hash and every dot to a hash to a dot? Every mirror exactly one smudge exactly one dot or okay, yeah. So we are allowed to change exactly one character in this grid to its opposite character between dot and a hash, and after that new grid is generated we find the same thing, and after it is found, let me do one thing, and they are saying that the first pattern okay, find a different line of reflection. What if there are multiple of them? Each pattern fixes much, find a different line of reflection. And for this test case only, they just changed this to a dot. And what did they do in the? They changed fifth symbol on the row 2. Symbol on row 2 to a hash. That made this as the answer. What I will do is I will check for how many of these interchangings we get a line of reflection. We get both a horizontal and a vertical line of reflection. The second pattern is much confusing. Okay, now the pattern has a different horizontal line, but does it have a different vertical line? Or do we not care about vertical lines anymore? area too much of exactly. They're only talking about different horizontal line, but they haven't said anywhere about the different vertical line. Summarize your notes as above, but instead use a new use the new different reflection line in this example. Okay, we only want the horizontal, right? But I think they haven't mentioned anything here. Because the first pattern is horizontal line, 3 rows above it. So 3 times 100 plus 1 times 100 is 400. And they are completely not taking any consideration of vertical lines. In each pattern, fix this merge and find the different line of reflection. What number do we get after summarizing the new reflection line in each pattern in your notes? Even in the example, they haven't mentioned anything about vertical lines. So let's say that we only care about horizontal lines. Even this sample output gives us that information, and it should have been clear in the statement, but it isn't. That's fine. That's part of puzzles, I guess. I will use a brute force approach. I will do it like this. Send this grid to this function. This is a vertical line, right? So this is, we don't need this anymore. And this, let me do one thing. I need to change everything to its opposite, right? And let me do it only for the sample first. And what I wanted to do, I will change everything. Suppose it try changing every cell. Let's say old value is stored in this temporary variable of ij. Of ij is old value is a hash, then it's a dot exit hash. Okay, and I will say that give me for now, let's say this returns count of horizontal lines found. So let's say we find it for these many, and let's send it to this function, which will do the same job as this one. I will take this. I need the matrix. I will keep it. Should I make it a copy? It's fine, doesn't matter. Or should I not? This should be constant and take it as a reference. This will do the same thing, right? If it founds let's for now keep this counter as well, which keep tracks of how many good horizontal lines that we found out, and return that instead. First, just to check whether we find exactly one this interchange. This is now a separate function, so removing it, and plus equals to this, and I can say that for this particular matrix I found swaps to a valid grid count equals to this many, and let's return found here just for debugging. For the second grid we found 10 different swappings. The second pattern is so what should be considered in this case? This example, the first pattern's new horizontal line has 3 rows above it. Let's see this. For the first grid, we only found 0, 0, which was top left. That's fine. And for this second one, okay, they have asked one more thing, that is what I need to consider. In each pattern fixes must find a different line of reflection. It may be possible that we always find the same line of reflection, right? So I haven't considered that. So let's do that first. I can return, since they are saying there is only one, so I will return, should I do here, since I'm returning the row only, so let's return answer from here, return row. Oh no, let's say this is not what I'm doing, and this is a set false saying that no, it's fine. And I will do this for the original one. Original horizontal line is equals to solve individual of this original matrix, and new horizontal line for this new matrix that we have changed the index ij of. If horizontal line is not equals to original horizontal line, then this is what we want, and I can return 100 times new horizontal line here. Think so this should be good. And I hope this will never get printed, and everything should be fine now. 100, and I might take in summation here. Okay, 300 is incorrect. I didn't print anything right. I only printed the final answer, so it didn't come here. And while it was here, I show. Okay, this should be fine, I guess. For this, zero and 4. Why is it 0? Should the answer be why is it 0? It should be 1 and above only, right? Horizontal line from 1 to this. So if it is good, I'm returning a value which is between 0 and n minus 1. So it must be this input, and am I not even printing this? 0 and 4, which is not correct. So horizon matrix, checking what is the first horizontal row before any changes. This should give me value between 1 and n minus 1. Why is it giving me 0 here? Okay, it found out it returned the counter maybe. Okay, it didn't find anything in that case, I guess. So maybe there is no horizontal line in that case, I guess. So what I can do is I can chain between 0 should be fine still. Is there really no horizontal line for this part too? It is shown here, right? This one. It's bad. So except this row, everything is followed. Let me assert here that we always find a thing. Is there anything to here with references? Let's try. Let's change this to old value here. Okay, the insertion is still failing. And for the first part, we did the same thing, right? So we just will run this, and let's say it prints. This is for. Okay, so see horizontal line found for this row, and this should print. Right, it printed 4. 4 is right or not? 0, 1, 2, 3, 4. Yep, this one. So it found a 4, but it only found it for one test case. It didn't find it for this one. The first one, I guess. Not. So what's the issue here? Let's compare. All the rows from 0 to n minus 1. Columns. Right. I mean, how can this be not right? Minus 1 and 4. Yeah, it's correct now. And then the answer is 400. Okay. I'm not sure why that was the case. And It sample input. The first doesn't find a horizontal line, but second one finds it at this one. Let's write on this last test case 1600 100. What if we want to add them for all of the possibilities and not just break whenever we find one? So 3 and 1 is perfect. So first pattern's horizontal line has 3 rows above it. That is what I have written here and under it. So answer 400 is fine for sample test case. Do I get the same answer again? Oh, now I get 160100. What the is that? Okay, let's check it. Initially I got 17100, right? Or not? Now what I wanted to do here is the sum up for all of them. Let's check. Still wrong. And why is it overflowing now? 10 minus 1. Is that why? And is it always possible that we will find a horizontal line? Line in each pattern in your notes. Solve individual. Let's check that this is also not minus 1. And it is not equal to this original. Otherwise it will just keep on adding. 800. Why did it do the same thing? Okay, understood. But this means it would do the same thing for exactly one dot or deposit type. Okay, it should be exactly one, but still if they're changing, this is changed to a, that means changing this to a hash is also a valid thing. How is that not counted? This can be made dot, and the entire this would have become a mirror for this row. How is that not considered? Expected 400, getting 800. So if I divide this by 2, hopefully that is my answer if I'm just blindly following the pattern. 24300. Answer is too low. Summarizing the new reflection line, and they are even not even saying that there can be multiple reflection lines. I'm not saying that there won't be, but since they have mentioned that there will be exactly one, let's try to do one thing. For all of them, let's say we find out this set of possibilities of those values, right? So first this would be this, and I will keep on adding it. And this one, only if it is not -1, and I mean it's fine if it's different, but yeah. And check for this grade. Possible values for this grade. Let's do this instead. C vector of int all possible, because I don't have debugging library for set. So I mean I haven't implemented it. It's not that I don't have it. The only doubt that I have now is they say that they changed this one character in this grid by this hash to a dot, which resulted in this, and this gave horizontal line, right? But if you change this character to a hash, then also it will give a horizontal line. Instead, it would have a different horizontal line of reflection. But initially, it wasn't even there. There was no horizontal line of reflection in this grid. So how did we do this in the part 1? So this was for horizontal line found, and let's see, we do new test case so that we check for which test case this would be printed. Yeah, I'm right. So there is no horizontal line in the first case, which is this grid. First vertical line shown at the top left or a dot. It would have a different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line of reflection between 3 and 4 now exists. 7 has no corresponding reflected. So 162534. The second pattern, the smudge can be fixed by changing the fifth sim model. Now the pattern 2 has different horizontal. Okay. Summarize your notes as before, but instead use a new different reflection lines. This example, the first pattern's new horizontal line has 0. Each pattern fix the smudge and find the different line of. What do you mean fix the smudge first? I mean that is wrong, right? So we first check what is defined as smudge. Discover that every mirror has exactly one smudge. Each pattern is locate and fix that smudge that causes a different reflection line to be valid. The old reflection line won't. Exactly one of these is of the opposite type. The first pattern smudges in the top left corner. If the top left has show a dot, I mean still the same confusion, right? So if I change, there was one smudge, right? So it was this character and this character, and changing one of them to the other means there are two ways, and both of them give the same horizontal line of reflection, but I'm counting them twice. But let's say I count them once, and I mean the answer would still be the same as we got earlier. So if I found, I simply break from here, I guess. Cancel. Let's forget about these. This is correct. What else? Here as well we go over all the rows, then the columns we go beyond. There could be one thing that I must have missed. If there is a mirror which has, let's say, its view area between this, let's say we are looking at this horizontal column at this third last row, and these two are the two rows below it, and these two are the rows above it, and if I change something here above it, then this would still be valid, and that would be added in the answer, or maybe give us a different answer. So they have mentioned that every mirror has exactly one smudge. So the mirror area that we are looking at, let's say for this particular case, it was only rows 1 to 6, it wasn't a 7. So let's say there was already, but in that case, this condition would take care of it. New horizontal line is not same as the original horizontal line, because if there was already, then it would have been caught by this original, and if I change something here and it still resulted in the same horizontal line, that means we have this condition violated, which won't be there. Still not able to figure this out. $400. I think it is fine if it, even if it is -1, saying that there is horizontal line already, or it is present now. No. This should be like this. In this test, they changed this to a dot. 0 1 2 3 4 0 1 2 3 4, this to a dot. That way these two are same, these two are same, these and these and then these, and that resulted, let me print one more thing, the original thing. Okay, I hope there are -1 for a lot of these test cases. It was a 10. Okay, it might be 1 0 1 2 3 4 5 6 7 8 9 10. Okay, so for this row it matches with this, hence this was a mirror. But like I said, one thing that I may have missed out is this is a part of this mirror, and this is not part of the original mirror. So how is that justified? One more thing I wanted to check is, what if there are multiple of these? So let's say possible are the things that we are looking at. You can return, let's say, I'm not using my answer here, right? So -1. If answer is -1, then answer is row, and possible dot pushback row. Let's print possible values of valid horizontal row, horizontal lines, and then return answer from here so that I can debug it clearly. This is what I wanted to do, right? Let's check. Now this possible 10 10 10 is because, where is that test case? We know that the horizontal line for this test case is 10 at this row, but even if you change multiple of the things anywhere here, so I hope these are, how many of these lines are there? 50 maybe. So it found this row and it made this as its final answer. This row, for this test case, it didn't have any horizontal line, but for the second pattern, this one can be okay. What was the original thing for this? Original was at 4 0 1 2 3 4. These two are same. These two are same, and these two are same. And we get a new changing the set small. this to a hash will make a different horizontal line of reflection with this much in the top left. As we saw for this case, it was 5 as well as a 10. For this test case, it is not even possible to make it. Or is it? I might stop the stream after some time if I'm not able to get this quickly. We are seeing that there is always a fix and a different line of reflection. Should I check my code instead? I always see either one or no possible horizontal line. So even in here it is found at some point. Let's do one thing. This is possible, and let's say we always get 1, so let's not do this thing. I think 500 looks correct for this test case, and didn't print anything for this. Nothing printed here. Why is nothing printed for the first test case? Okay, that's fine. Okay, we get multiple not founds, and they have mentioned in each pattern fix this merge and find a different line of selection. So not found means we tried all of these swappings. So we changed every cell from one to the other, and am I updating this correct? Need to check this. See, reference is not there even here. I mean, old value is not even needed. Simply do this thing again. Solve for this matrix. I mean, what do we do for the not found case? I hope that is the main issue. Let's also print what was the original thing for those not found. We don't get anything for the samples. All of these are -1. In each pattern, fix this merge and find the different line of reflection. What number do you get after summarizing the new reflection line in each pattern in your notes? Let's try printing this just to check whether maybe it was possible and there is something wrong in my implementation. Mm, okay. These tests, I mean, let's see if there is a smaller one. That much may even be one character which makes the first two rows or the last two rows as mirror sequences. For this test, no. When this cannot be, this cannot be. They are saying that each pattern, each grid has exactly one smudge, but I'm finding these test cases for which it is not there. I mean, now the question is, am I not considering the verticals? Maybe. I mean, they haven't mentioned anywhere about not considering the vertical lines. I have considered the question the same way from the beginning only. Summarize the notes as above, but instead use a new different reflection lines. In this example, the first. Maybe there was no vertical lines found. That's why it is zero contribution. Or maybe once we find a smudge, but we don't find them in these cases, maybe it is present in the particle case. I can say this is one vertical thing, the last two columns. And let's do one thing. If we don't find a horizontal, we check for the vertical. I mean, do I have to do the same thing again? And for vertical, we only take the rows below it, left of it. That would be small. Don't find horizontal. This is already very bad. So this is the issue. We are finding some vertical lines for this columns. We're not finding it. Okay, wait. One more thing that I've missed is I have swapped the character just after the call for this is over. Wait. Okay, this should be here. Check now. Let's change this output as 500. It's even smaller output. This cannot be the answer. They already said the answer is low for 16,000 something. Now I'm trying for 337. Please wait 5 minutes to try again. Wow. I mean, this should. Let's do one thing. Do this separately after the horizontal thing is done. So I want to do this here. Horizontal is, wait, no, looks fine. Vertical line, solid is vertical. Let's rename this. And I hope for the verticals as well. I mean, I'm just assuming that this is what we need to do. It should be wrong, but let's find out anyways. Okay, I get 16083, but before that I got 16100. They said it was too low, so I think this is still a wrong answer. This would give me an error, but let's see. And this time it didn't find anything about not found, right? Totally haven't given anything about the vertical thing. Number of columns to the left of each vertical line of reflection to that also add 100 multiplied by the number of rows. What if once we find that smudge, it may be part of a vertical mirror and a horizontal mirror? This will be the last attempt. I will close the stream after this. Let's see. reflection lines. I mean, this is very unclear question, I think. They haven't given anything what we need to do about the vertical thing. One thing that I forgot here is, let's say I don't consider this vertical, right? Initially I was getting the answer as 16100, and now I'm getting a smaller answer after counting, after adding something in it. I don't think that makes sense. See, this answer only for horizontals is more than counting horizontals as well as verticals. There must be something wrong. Because I'm returning from here. Is that the case? Maybe. Even I'm returning from the next case, right? Why is it going negative? I mean, if this is -1 in that case. Right. Four nine zero nine six. 49096 by 2. 24548. 24548. Okay, that's enough for today. I will push this just for backup. Thanks for watching.